So let's look at another example where we're going to analyze the graph of our rational function. We want to look at this and we want to factor it because that makes it easier to determine the domain when we look at the denominator. I can look at this denominator as it is, and it's not going to do me any good to factor this function. So let's go ahead and determine where is the denominator equal to 0. Well, it's equal to 0 at 0. So the domain of this function says that I can have all those values, all real values except 0. So the domain is x such that x cannot be equal to 0. That's the one number I would have to throw out. Since we can't reduce this is kind of not applicable in this particular example, but we're going to move on and we're going to talk about the intercepts. Remember, the intercepts occur one time. I'm going to go ahead and let x be equal to 0 to find the y-intercept. And I'm going to do it again when I let y equal to 0 to find the x-intercepts. So come over here to the function. We're going to replace all of the x's in that function with 0. So this would look like 0 squared minus 1 divided by 0. And what happens when I have negative 1 divided by 0? I can't have that, right? So that means there is no x-intercept. Okay, so no x-intercept in this particular case, or y-intercept, excuse me, no y-intercept, I should say. And so no y-intercept occurring. And then we're going to go in and we're going to take the function and we're going to set it equal to 0 to find the y-intercepts this time. So I have x squared minus 1 over x is equal to 0. I can cross multiply or multiply both sides of this equation by x. Cancels those out, leaving me with just x squared minus 1 equals 0. And therefore I would have x squared is equal to a positive 1. Take the square root of both sides, and you see that we have intercepts occurring at positive and negative 1. These are the x-intercepts for positive and negative 1. Next, let's move on to the asymptotes of our function. So the asymptotes are, for the vertical asymptote, remember that's where the denominator was equal to 0. We know that the denominator was equal to 0 when x was equal to 0. So that's one of the asymptotes. Now the other asymptote, whether it be horizontal or oblique, we want to first, we want to go back and we want to determine the degree of my function. So I'm going to scroll back up here. And the degree of the numerator is 2. The degree of the denominator is a 1. So I know that 2 is greater than 1, and because it's only a difference of 1 in between the two degrees here, we're going to use long division to find the oblique asymptote. So when we set this up, x is on the outside of the house, the numerator x squared minus 1 is on the inside of the house, and we move on with our long division. So you're going to ask yourself, what do I multiply this number on the outside by? What do I multiply x by to get x squared? Well, x, because x times x is just simply x squared. We would subtract this, those cancel, bringing me a negative 1, and I'm really done with the long division right here anyway, because I can't turn an x into a negative 1 for our purposes right now, and we have a linear equation showing up already. So we would say that the oblique asymptote is going to occur where y is equal to x, using our long division. Now let's come down here to the graph and let's put all the information that we know so far on our graph. Okay, so on my graph I have labeled the vertical asymptote here that we found at x is equal to 0. I have the oblique asymptote labeled here at y is equal to x, and I have the two intercepts occurring at positive and negative 1. So we turn to the calculator to see how do I draw this function. Entering the function on the y equals x squared minus 1 divided by x, when I graph the function, you can see here kind of this imaginary oblique asymptote kind of passing through my function. And so I know that I have some sort of curve occurring here on top of that, and then another curve occurring over here below that oblique asymptote. So if we go back to my function, I can now graph it, and I would kind of come this way, passing through my intercept and then skirting along the vertical asymptote, doing the same thing over here. Oops. Let's try that again. See if we can make it any prettier. Let's try it again. So we're going to skirt along that, and then we have this function graphed as well.